All right, so here's another problem I thought you might need some help with. This is problem 23 on your packet, and it's a related rates question. And because related rates is most recent in your memory, this might be easy, but I thought I would still show you anyways because it's a good example of how different equations need to be used when you're trying to relate different rates. So for number 23A, you got the question is how fast is the top of the ladder sliding down the wall at the moment given? So the moment given, you got a 13-foot ladder sliding down the house. The base is 12 feet from the house at this given instant, right? So I'm not putting the 12 feet in there. I'm just going to call that x for right now. And also the base is moving at the rate of 5 feet per second. So there's a rate that I know. So I know dx dt, the way the base is moving. So I know the rate of change of x, dx dt is 5 feet per second. All right. And the question asks me how fast is the top of the ladder sliding down at the given moment, which is dy dt. Well, this is kind of fortunate because I'm pretty confident I can come up with an equation that relates x and y. And this is a pretty common example of when you use the Pythagorean theorem to relate this. So the house and the ground make a right angle. The ladder is 13 feet all the time, so that's not a changing value. So I don't have to take that into account. Sometimes I do, but in this case I don't. So I'm just going to come up with the equation that relates the rates. All right. So at this point, I differentiate it implicitly and then plug the values that I know at the given moment. So 2x dx dt plus 2y dy dt. And I didn't even have to do 13 squared derivative. I know it's going to be 0 because it's a constant. So at any rate, I got everything I want to plug in. I know that I'm looking for dy dt. That's the only thing that I don't know. In fact, at this given instant, I know x. I didn't actually know y. So at the instant, you got to be careful when putting these values in there. I'm going to put the 12 there, but at this given instant, it's 12, 13. And if you remember your Pythagorean triples, I'm not going to go through the Pythagorean theorem, but y would be 5 at that given instant. So I can plug in all these values. So 2, x is 12 at this instant, dx dt is 5, y at this given instant is 5, and dy dt is what I'm seeking. So then you solve this equation for dy dt. I could go through all the steps required to do that, but I'll just give the answer, or you could find it on your own. But again, essentially I get 120. 2 times 12 times 5 is 120. Subtract that, so I get 120 divided by negative 10. So why does it make sense? So my rate of change here, when it's all said and done, dy dt is negative 12 feet per second. And it should make sense that it's negative because the ladder is sliding down the house. So the rate, the value of y is decreasing at a rate of 12 feet per second. Moving on to part B. So what's the difference? So now it says, what is the rate of the area of the triangle formed by the ladder, wall, and ground changing at the moment? So now I seek the rate of change of the area. Once again, I know some things now, actually. I actually know dx dt is still 5 feet per second. And I just found dy dt, which is helpful because I'm going to need that when I find the area. And now I need an equation that relates these rates. Well, it's pretty easy. What equation relates area given the base and the height of a triangle? What's the area of a triangle formula? So the equation that relates the rates is area equals 1/2 base times height. In this particular problem, base is x, height is y. So now when you differentiate this thing implicitly, I get dA dt equals 1/2, and then it's the product rule. So it's first x times the derivative of y plus y, with parentheses around this, times the derivative of x with respect to t. Okay, and now you plug in everything you know. Again, I know everything here. I know that I'm looking for dA dt, and I'm plugging in everything. So I knew x at this given moment was 5, 12. So 12 dy dt we found was negative 12. Y at the given moment was 5. And this is all, again, from the last problem. I got x, I got dx dt, I got y, I got dy dt. Dx dt at this given moment was 5. So then I multiply this. So how is the area of the triangle changing at this given instant? It's going to be changing at a given rate. So I'm going to multiply these in. So negative 12 and 12 is negative 144. I'm going to add that to 20. I'm going to add 25 to that and then take half. So negative 59.5 was the answer I got. And I need to come up with the correct units. So how does area change? Well, area is units squared, or in this case, feet squared. And it's still per second because everything else was happening in seconds. The unit of time is seconds. Okay, so I got two answers here, and I'm gonna try to get the third. So now the last one, C. At what rate is the angle between the ladder and the ground changing at the moment? So you're like, okay, well, angle right here is theta. So once again, I need to figure out what do I seek and what do I know. Well, it tells me what rate is the angle change. That's the question. D theta dt. And I know actually the rate at which x is changing. Dx dt. I knew that from the first problem. He actually gave that to me in the first sentence. So I know dx dt is 5 feet per second. So still the same question, still the same situation. I just now have to come up with an equation now that relates theta to x. All right. So now I'm thinking trig functions. Well, the 13 isn't changing, so I'm going to probably want to use that. So I'm going to come up with a trig equation. In this case, that's going to be the cos of theta is equal to adjacent x over hypotenuse 13. So there's my equation that relates the two rates. I'm looking for theta, and I know x, so I'm going to come up with an equation that has those two variables in it. And that's the idea. That's why it's called related rates. So I'm going to take the derivative implicitly. So the derivative of cos theta is going to be negative sine theta, but chain rule says I got to take d theta dt, which again, that's what I'm looking for. And then the other side, I got the derivative of x over 13, which is just going to be 113. But chain rule says, again, I got to take the derivative of x with respect to t. So now you get to this point, and you're like, okay, I know dx dt, but I don't know theta at the given moment. All right, I can find that, though. So this is where your trig comes into play. So I know x at the given moment, if we go back to the beginning, x at the given moment was 12 feet. Okay, so I know that at this given instant, x is 12 feet. Well, that'll help me find theta at this given instant. So at this given instant, I can say the cos of theta is 12 over 13. Right? Again, be careful, because I didn't use that in the equation because it was an instantaneous thing and it's changing. So I don't want to put that in there. I don't want to put things that are changing into my equation that relates rates. So at any rate, at this point, you want to find theta, so it's going to be cos inverse of 12 over 13. At this point, you could use radians or degrees. Doesn't really matter. But this is going to tell me what theta is. So I'm going to use degrees just because it's a little bit nicer. Makes a little more sense. So second cos of 12/13. And my calculator is in radians, but I'm going to change it. I got 22.662, we'll say. So 22.62 is theta. So again, in your calculator, and that's in degrees, in your calculator, leave that in there. So now I could take negative sine 22.62 d theta dt equals 1 over 13, and I know dx dt is 5. So now I'm going to take and see how theta is changing. And you imagine that theta would be, so I'm going to take negative sine of what I got of answer. So it's going to be negative 0.385. Keep the same color. So negative 0.385 d theta dt equals 5 over 13. So now you divide by negative 0.385, negative 0.385, and you should be able to see d theta dt. It's going to be 5/13. So in your calculators, you can do this, or you can just wait for me to do it. It's kind of boring. 0.385. So I messed up. I'm going to put a parenthesis in. Okay, cool. All right, so I got negative 0.999999. So I'm going to assume that if I use the actual decimal, that theta would be changing at a rate of negative 1 degree per second. Okay, I hope that helps, and hopefully you guys can do better on your related rates questions and your final after looking at this question. All right, hopefully that helps.